Hi, in this tutorial we are going to solve a question related to proton NMR. The question asks how many sets of peaks are expected for the following compound in H1 spectrum. Let's start solving the question. In order to determine how many different peaks or sets of peaks we expect in the spectrum, NMR spectrum, we have to identify different type of hydrogens. Let's start explicitly showing hydrogens. So we have two sets of hydrogens. We have here a carbon-carbon double bond, which is a vinyl type hydrogens we expect to find here, and here we have benzene ring. We are expected to find aromatic type hydrogens. Okay, let's place the hydrogens here. Let's use red color. So there are here two hydrogens, and there is one hydrogen, and here on the ring we have hydrogen on this side and on this side, and we are labeling them and showing them explicitly. Okay, then let's start from the vinyl group. This molecule actually is styrene. It's a molecule for used in polymerization reactions. Anyway, let's go for NMR spectrum. Here we have two hydrogens. We have to determine whether they are equivalent hydrogens or not. So since this part is a carbon-carbon double bond, the rotation is restricted, so the position of this hydrogen and that hydrogen, they are fixed. So this hydrogen is facing a hydrogen on the right side and next to this hydrogen. So basically chemical environment is we have here a vinyl hydrogen, on the other carbon, on the same carbon we have another hydrogen. Okay, so we discuss for this one. For this one, this vinyl hydrogen is facing the ring, aromatic ring, and also it's next to the other vinyl hydrogen. So basically, chemically they are different. So we expect to see two different signals in NMR spectrum for this for these two hydrogens. For that reason, we can say or we can number as like, or we can label as A and B. So two different peaks expected in NMR spectrum, and the other vinyl hydrogen of course is expected to appear in a different location in NMR spectrum. So let's say this is C, and let's move to aromatic ring. Here we have two hydrogens on these two carbons, and since the molecule is symmetric, we can say that this hydrogen and that hydrogen, they are equivalent. So we can say this is, we said A, B, C, and let's say this is D and this is D. And again, the next carbons, they are like, since they are symmetric, the hydrogens have to appear on the same place on NMR spectrum. So we need to say E and E, and we have one hydrogen here which we say F. So let's count how many different types. 1, 2, 3, 4, 5 and 6 different hydrogen signal or proton signal we expect to see in proton NMR. Thank you so much for watching this video.